Okay, so this is Thursday, May 4th, and this is going to be the rest of section 10.3. And we're sketching an ellipse in this problem. And let me get rid of that. And we had gotten pretty far, so we know that the center is at -3, 1, and we know that a squared was 4, and so a is plus or minus 2. We found some vertices, and we had just gotten to the point where we had said that b was equal to or b squared was equal to 1, so b is equal to plus or minus 1. I'll change to a different color just so that if you're gone, you kind of know where we are. So that is going to tell me my endpoints that are up or down. And so from my center, when I'm at -3, 1, I'm going to change just my y value using b. So one of my vertices is going to be -3, comma 1 plus 1, which is -3, comma 2. And the other one will be -3, comma 1 minus 1, which is -3, comma 0. So for this one, I'm going to have my center and my vertices. Let's plot those first. And I don't have my foci on here yet, but I'll do that kind of next. So here's the points that I need, just so that you know. I need my center, which is -3, 1. I need these horizontal points, and then I need these 2 vertical points as we go. And so I won't be able to see those anymore as I'm graphing them, so you can help me a little bit as we go. So one of those points, the center was -3, 1. So 1, 2, 3, 1. -3, 1 is the center. And then since a was 2, then we go back to -5, 1. And this one is at -1, 1. So those are our vertices there. And then my up or down ones are at -3, 2 and -3, 0. So with those points, I can just sketch in my ellipse. And just like, you know, when you've done things like trig functions or drawing a circle, as long as those key points are there, if you miss the actual drawing of, that's usually not a big issue for me. The next thing we need in this one, bless you, is where the foci are. And so I'll just add a little, I don't have a huge amount of space here, but I'll add that here. And if I go back to this other slide, I'm not sure where it exactly is right now, or I missed it. Nope, I did not. It's maybe here. So when we're looking for the foci, we're going to use this equation, c squared equals a squared minus b squared. And so now I'll go back to our problem and find that. Sorry for paging through all this. And there we are. So for this one, we know that c squared is equal to a squared minus b squared. And, you know, we have a squared and b squared from kind of right here from earlier, or, you know, right here, or we have a and b. So we can use kind of whatever version of that we want. And we'll just write in here that c squared is 4 minus 1, so c squared is 3, so c is plus or minus the square root of 3. And for that one, we go from the center again, left and right. And the reason why we're going left or right is because our major axis was horizontal. So we decide where our major axis is, whether the whatever the longest axis is as we go through. So this will go left or right from the center. If it was oblong up and down, we would go up and down from the center. Oh, I used a squared and b squared. Yeah, so it's a little deceptive because b is 1 especially. So the square root of 3, am I right in thinking that's about 1.7? Okay, let me see. I think it is. Okay, so we're a little calculator light right now. Um, so to find our foci, since it goes left, right, I'll just write left, comma, right. We'll say that it's from the center, -3 plus the square root of 3, comma, 1 will be one foci, and -3 minus the square root of 3, comma, 1 will be the other one. And so this one is going to be, I think I have it written here, it's a little small for me to see, -1.3 comma 1. And this one is about -4.7 comma 1. Two things I'll tell you. In any of these situations, if you get a radical, I will expect to see it as a radical and know that that's what this is. But then for performing and putting it on a graph, of course, we have to get a decimal for that. So just a note to self that we want it as a radical as the exact answer, and then we can also put it in a decimal form. So let's see, -1.3 is a little past 1 here, comma 1. There's one foci, and then negative 1, 2, 3, 4.7 is the other foci. So focus, excuse me, singular is focus. So that's what that one will look like. I have one more problem for us to do, and so if you weren't here, or you know, this will be a recording of a full problem that might help. So we have to find the center, the vertices, and the foci of the ellipse. And by the way, those are all different kind of answers as we go. And then we sketch the ellipse. And so this one is number 3. I'll just kind of restate it. 4x squared plus y squared minus 8x plus 4y minus 8 equals 0. And yesterday we said we're going to separate these into x things, y things, and then on the other side of the equal sign we'll put any numbers. So we're going to kind of regroup them. I'll use color again. So I have 4x squared minus 8x, and then I'll just put my plus blank because we're going to complete the square. And then plus y squared plus 4y plus blank, because we're going to complete the square there as well, equals, and I'll move that 8 over, so I'll add 8. So that's equal to 8. And so this one isn't super different than the other one, but so it's kind of a little comforting to try something kind of the same. When we're going to complete the square, just a reminder that we need to factor out the 4 there. So this is going to be 4 times x squared minus 2x plus blank. And then on this other one, I think I'll just kind of complete the square as I go. So y squared plus 4y plus, and what do I have to add there? Then square it. 4. So to know what I'm going to add there, I take this y term, divide it by 2, and then square it. So 4 divided by 2 is 2. Squaring it is 4. So that's what I'm going to add on this side to keep things the same. I add it over there as well. So then on this other one, when I complete this square, -2 divided by 2 and then square it is 1 squared. -2 divided by 2 is 1 squared, and then or -1 and then squared is 1. So I'm adding 1 here, but when I'm adding 1 there, I'm really adding how much? 4. So I have to subtract 4 for that one as well. So now I can write this in a little more general form. I'll kind of go to one color now. I'll leave the 4 out there. I'm going to write this as a binomial square. So x squared minus 2x plus 1 is x minus 1. That middle term determines the negative there. And then plus parentheses y plus 2 in parentheses squared, and then equals on the other side is 8. Now the things I have to get rid of is I have to get rid of that 4 that's out in front, so I'm going to have to divide everything by 4. I also have to get rid of the 8 over here because that has to be 1. So I can, oh wait, I did something wrong. Yes, I should have added the 4. So good thing I looked at my notes just now and I'm like, wait, that's not what I have over there. So my bad. This was plus 4 and this one should have been plus 4. And do you know why I subtracted 4? Because if we're on the same side of the equal sign, I have to add it and subtract it. And sometimes when I'm doing a function, that's what I do. So that should have been 16, my error there. And so now corrected. And so to get this 16 to be 1, and at the same time it'll get rid of that 4, I'm going to divide all of my terms by 16. And let me slide this up a little ways. So then for this one, I get x minus 1 in parentheses squared over, well, the 4 and 16 cancel to be a 4 there, plus, and then y plus 2 in parentheses squared over 16, that just stays, equals 1. So then for Riley, who was gone, in that last problem that we were finishing, the bigger number in these two denominators was under the x's. And so that meant the major axis, or the longer part, was horizontal. Now the bigger number is under the y. So our longer part, or major axis, will be vertical. And that also changes a and b, because a is always the big one, just to kind of let you know that. So I'm just going to write a little note. So this is the bigger number, and so the major axis is vertical. Vertical. And so then I'm going to write my general form as well. So now it's x minus h in parentheses squared over b squared plus y minus k in parentheses squared over a squared equals 1. So the little trickiness is that, you know, kind of the A and B switch spots because A is where the bigger number is, and that also means that it's going to be a vertical transition as we go. So now we'll find all the parts. So the center is HK. And so it's x minus h, x minus k. So what's the center? 1, negative 2. And then to figure out our vertices as we go, a squared is 16. So what's a? Plus or minus 4. Plus or minus 4. So to get our vertices, and the a is going in what direction? Up or down, or left and right? In this case, up and down. In the last one, it was left and right, but now our A is going to tell us a left or right number. So we're going from the center. So our vertices are going to be 1 comma negative 2 plus 4. And the other one is 1 comma negative 2 minus 4. So they are 1 comma 2 and 1 comma negative 6. And I think I'm going to just in yellow circle all these things so I kind of can see them. Because I go down because of space, but then I feel like it gets a little harder for me to find everything. So then I do the same thing with b, right? So b squared is 4. What's b? Plus or minus 2. But now b is going in what direction? left and right. And so I'll keep this one at 1 plus 2 comma negative 2. And the other one will be 1 minus 2 comma negative 2. And then that's 3 comma negative 2 and negative 1 comma negative 2. And again, I'll go back to that circling in yellow. And do you agree that those 4 points that we just got are on the ellipse? And we have the center. And so now we need also the foci for this one. And to find our foci, we have, c squared. I don't know why I was doing that. C squared equals a squared minus b squared. And it's always in that order, and you'll just know you made a mistake, or you have to reconfigure things, because a should always be the bigger number, right? And so if we're going to subtract and not get imaginary numbers, then we want to just kind of remember that that's the case. And they're squared already up here, so c squared is 16 minus 4, c squared is 12, and c is the square root of 12, which is, or plus or minus, excuse me, the square root of 12, which 4 goes in there 3 times, so it's 2. C is plus or minus 2 the square root of 3. And just a little reminder, that I want to know what those are in simple radical form. And now the foci, since this is a major axis is vertical, the foci are going to go up or down from the center instead of left or right this time, correct? And so you just kind of always have to keep that in mind. In my head, it should be what you would expect, but sometimes it doesn't always seem that way. I'll write this here. So the 1 stays, and then it'll be the negative 2 that you're moving from. So 1 comma negative 2 plus 2 the square root of 3. And the other point is 1 comma negative 2 minus 2 the square root of 3. And then for decimals, I'll just tell you what those are. 1 comma 1.46, or close to 1.5, and 1 comma negative 5.46, or about negative 5.5. Oops. So, okay, so the actual answer, these are the points that I'm plotting. So maybe I should do it this way. That's a good question. So the actual answers are these things, that is the answer. But then, of course, to plot it, we have to plot this. Do you know what I mean? So obviously I want you to plot something that's plottable as we go. So yes, if I asked for the foci on the test, that is what I want, the radical expression. But of course, for the convenience of plotting things, we want to have it like this. Okay, again, I can't see these, but let me know if I make a mistake. 1, negative 2 is the center, so I'll just kind of put that on there. And then 1, 2 is a vertex, or vertex, or a point on the ellipse. And then 1, negative 6, 2, there we go, is another point. And then, is it 3, negative 2? Okay, 1, 2, 3, negative 2, and it must be then negative 1, negative 2. So then I can kind of draw in my ellipse. It's as good as that's ever going to get. And then I have 1.46, so there's 1, kind of. And of course, as long as we have the actual number, and you might want to show the rounded number. Okay, just hang on a second. And then 1 comma negative 1, 2, 3, 4, 5.46. Okay, so there, like in, um, the question is, what are the foci as we go through this? And so if you watch my notes from when I was gone on Monday, I went through this a little bit. But like if I was going to draw a circle, let's go back to a circle, you know, it has a center and a radius, right? So if I take a string and a piece of chalk, you know, I can kind of do this, right? Well, the way this works is if I take and I kind of attach that my string here, and then I kind of add these two lengths. Notice one gets bigger. They're always the same thing. Yeah, that's as. So they help us draw actually where the exact points are, even though we just start tracing it in. Do you know what I mean? So that's kind of what that gives you there. And that is everything that we're doing in this section. So I'm going to stop this recording and then I'll just start another recording for the other part. So